This video is for geometry students who are struggling with some of the Chapter 1 concepts still. So we're going to talk about angle relationships and some segment relationships and how to solve those problems. Okay, first we need to get some vocabulary down because some of you are really struggling with what this vocabulary means and there's really no excuse. If you need to get some flashcards out and write these down along with a picture of them, then you need to do that, because this is a memorization tool. You can't go any farther in geometry if you can't memorize some of these terms. So, I have a figure here, and we're going to talk about some of these angle relationships in the figure. The first one is adjacent angles. Adjacent angles share a side, okay? But they cannot be inside of one another. So, A, B, and H shares a side with H, B, G. Those are adjacent angles, okay? There's a lot of adjacent angles in this picture. ABC and CBD are adjacent angles. DBE is adjacent to EBF. If they share this side, but they're not inside each other, then they are adjacent angles. Okay? Complementary angles add up to 90 degrees. So in this case, you're looking for a little right angle mark. And I see one right here. That tells me, since it's stretching over two angles, that this angle plus this angle equals 90 degrees. And I wrote that down. ABC and CBD are 90 degree complementary angles, excuse me. Okay? They don't have to be next to one another. They don't have to be adjacent. In this case, the ones that I chose are adjacent. But as long as two angles add up to 90 degrees, they are complementary, whether they're next to one another or whether they're not. Okay, vertical angles are always formed by two straight lines. So whenever I'm looking for vertical angles, I'm looking for something like this line and this line. Not this one. See how this one's just a ray that comes off the middle? It's not a straight line. I'm looking for two straight lines. That tells me that this angle and this angle are vertical angles because they're formed by two straight lines. That's very important because vertical angles are always congruent and we can use that relationship. So I chose HBG here and EBD. Notice they're going to have the same vertex because vertical angles always meet there at the point in the middle. There are other vertical angles in there. Let's see if we can find one. If I used this line and this line, then I would find a little angle right here and a little angle right here. Those two are vertical angles to each other. Okay? So if you need to pause this and jot down these notes or make your flashcards, then you can do that at any time. That's why a video I find to be helpful is you can just say, "Stop, Mrs. Brewer." You can do as much time as you need to work out a problem or copy something down, and then you can start up again. Okay, so let's take a look at some of this. If I give you a figure like this, you ought to be able to fill in every angle measure on there. Okay? So let's take a look. You're given that this DBE is equal to 50 degrees. Measure DBE equals 50 degrees. What is the measure of FBE? So let's go find FBE. FBE, right here. Okay, well, hopefully you looked at that and you saw a cute little right angle mark, just like I did. If that together they make 90 degrees, the relationship is these are complementary angles. The equation is 50 degrees plus the angle I want equals 90. So this one must be 40. Every time I ask myself that same question, what's the relationship and then what's the equation? Because the equation comes from the relationship. Okay? So these have to equal 90, so I just subtracted to find that angle. What is ABG? Let's find ABG. ABG right over here. Well, I don't see anybody next to it that's part of a 90 degree angle. This one's its own 90 degree angle, but this one's not. So let's see. I notice it's part of two straight lines this way, so it's vertical to DBE. So if the relationship is that they're vertical, then I know that these two angles are congruent. So if this one is 50, then the angle I want is 50. Okay? Now, let's ask about CBD. CBD is right here. Well, it's not vertical to anything because there's no straight line connecting over here. But I do notice that this angle, and this angle are all making up a straight line. And I know that a straight line always equals 180 degrees. So my equation in this case would be ABG plus ABC plus CBD equals 180. Because I know this one, see it? This one must be 90. 50 plus 90 plus this one equals 180, and that's the equation that I wrote. So I subtracted and got that this one equals 40 degrees. Okay? I have one angle left all the way around there. And you'll notice I have a straight line here. This half of the straight line is a 90-degree angle. So this half, since they equal 180, has to be a 90-degree angle also. The angle of measure of angle GBF. So just knowing one angle, we were able to move our way all the way around and find vertical angle relationships, find complementary angles. We found supplementary angles, and you should be able to do that same process. What's the relationship? What's my equation? These are the kind of questions that you're going to get. A and B are supplementary. If measure A equals this and measure B equals this, what does each angle measure? First thing I ask myself, what is the relationship? Supplementary. Which I don't know what happened here, but I spelled that wrong, but you'll spell it right. Supplementary, okay? That means angle A plus angle B has to equal 180 degrees. That's the definition of supplementary angles. Before I write any relationship, I say to myself, what lets me write that relationship? Definition of supplementary angles. They told me they're supplementary, and that's what it means. So now I can substitute in. I could put in 2x plus 6 for angle A, and I could put in 6x, sorry, I want to make sure this is right, 3x minus 1 for angle B. Now to solve it, I combined my like terms and got 5x plus 5. But I want you to notice something. This was plus 6 and this was minus 1. So many times students will tell me that that's going to be a 7. Positive 6 but minus 1, when I put those two together, that's going to give me 5. So make sure you pay attention to your signs when you're combining your terms. So I subtracted 5 from both sides and got 5x equals 175. Divided both sides by 5, because that was in front of my x, and I got x equals 35. But they asked me, what is the angle measure? So my last step is to go back and plug it back in. 2x plus 6, 2 times 35 plus 6 is 76. And 3 times 35 minus 1 is 104. And since they're both supposed to add to 180 together, I just quickly checked my work by saying 76 plus 104, and it does equal 180, so I felt like I had gotten the problem correct. Okay? Think about all of these steps. Now, if you're getting comfortable, you might do these steps automatically. You just see immediately they said supplementary, you wrote the relationship, and that's great. But if you're unsure, I want you to every time ask yourself, what is the relationship? What is my equation? Plug in my numbers, and then solve it algebraically. Okay? Here's another case you might get. XYZ is bisected by ray YP. The measure of XYP is this, the measure of PYZ is this. I need a picture. When I start seeing different letters and things going on, they didn't give me a picture, I will draw it. So I just drew an angle XYZ. I didn't know how big to make it, and it doesn't really matter. So I drew XYZ, and then they said a ray comes from Y and goes out, so there's my YP. And notice the little congruent marks that I made on those angles. Why are they congruent? Because bisect means cut into two congruent parts. So that's what happened here. Now I have a better idea when they start giving me letters, I can see which part they're talking about. So draw that picture. What is the relationship? XYP equals PYZ. Why? That's the definition of a bisector. Okay? So I set this up here, and now I'm going to substitute my values in for each one of those. 4x minus 4 equals 2x plus 8. Do our math. We added 4 to both sides. We subtracted 2x. And we got down to x equals 6. All right? Let's plug it back in. 4 times 6 minus 4, I get 20. Okay? If I plug this one in, I'll get 2 times 6 is 12 plus 8 is also 20. Double check. But I knew already that they had to be the same because they're congruent. If one is 20, the other's 20. Now sometimes questions will ask you, what is angle XYZ? So if you write 20, no, because we got 20 here, and we got 20 here, so if I wanted the entire angle, it ought to be 40. Okay? Now you can see I drew an obtuse angle in my original picture because I didn't know what they measured. It doesn't matter. As long as I know that the two parts together are congruent and they make up the whole. So this is what the whole angle measures. This is what each part measures. Pay attention to what kind of problem they ask you. Let's talk a little bit about segments. A lot of the rules of segments are exactly the same. What some people are doing, though, is sometimes they're adding up segments to equal 180 degrees. Segments don't have any degrees. So make sure when we're working with angles, you worry about those 180s. But when we're working with segments, that you make sure you're looking at whatever number they give you for the length of the segment. Okay? So for example, we have a segment ABC. Okay? If AB equals 3x, BC equals 7, and AC equals 22, what is AB? Well, first of all, I like to mark things up. If AB equals 3x, I'm going to write a 3x right there. If BC equals 7, I'm going to write that right there. And AC, the whole thing, equals 22. It keeps me from putting the wrong thing in the wrong place and making a mistake. So, I know the relationship is that part plus part equals the whole. AB plus BC equals AC. We call that the segment addition postulate. That means I can add the parts to equal the whole. Now, why didn't I set this equal to this? They didn't say. They didn't say that B was the midpoint. They didn't say that B bisected the segment. All they told me that it's somewhere between. So you can't assume, unless there's some marking on it to tell you that they're congruent, don't make them equal. Okay? So the relationship is that I can add the parts to equal the whole. And that's exactly what I'm doing. I'm going to substitute it in. The first part was 3x, the second part was 7, and the whole is 22. So 3x equals 15, and x equals 5. So this side must be 15, right? Because 15 plus 7 equals 22. Right? Now I want you to compare this one to the problem down here. I still have ABC, but notice what's different. What do these marks right here mean? Now I have AB equals BC. Those are congruent marks. Now I could write the equation AB equals BC if that's what they gave me. Notice though, it's still AB plus BC is still going to equal the whole thing. That's always true. But sometimes when they give you that they're congruent or they tell you it's a midpoint, you'll also be able to use the relationship of one equals the other. Okay? Oops. My last thing that I want you to do is a little problem yourselves. So, I've given you KLM, and I'm asking what is the value of KM? So KL is this expression, LM is this expression, and KM is this expression. So think about the relationship. Does anything in that figure tell you that anything is equal to anything else? Okay, so make sure you write down the relationship. If you need to pause this, write down the relationship, and then I'm going to give you a second, and I'm going to check it. This is what I got for the relationship. Part plus part equals the whole, because nobody told me that they were congruent. Nobody told me that L was a midpoint. Okay? So now my equation must be, write down your equation. Oops. I'm using this high-tech cover here. I wrote 6x plus 3 plus 2x plus 9 equals 12x minus 4. So the only trick to this is making sure that you're keeping each part in its right place and you don't accidentally switch them up. So then I'm just going to combine like terms, okay, and solve out my algebra and get down to x equals 4. So now I plug back in to Km because they asked me Km, and I did 12 times 4 minus 4. So 48 minus 4, I got that the Km equals 44. I could also find out what each of the segments is if I wanted to by plugging that x back in here. They did not ask me the question. Okay? That's it.